pharmacology class. Quickly, let's do a short review of antiviral drugs. And specifically, we look at antiretrovirals. It's important for us to know that viruses are known as obligate parasites, that they lack some major machineries that most living organisms has. So they depend on other living organisms for survival. Now, case in point, we're looking at HIV. HIV, human immunodeficiency virus, requires a living host to survive, multiply, grow, and continue to live. So it is, we know that we have two types of HIV infection, HIV type 1 infection and type 2 infection. Both of them will then lead to AIDS. HIV type 2 is the variant that is known to be found in Africa, especially West Africa. It is, I think the virulence of this version seems to be lower than type 1, and the rate of transmission is also lower, and possibly it's progression to AIDS is also slower. Now, having talked about HIV, no, we know that HIV wants to enter the immune system, and it wants to co-opt, make some part of the main component of the cell, like the DNA component, to be able to make copies of its own protein and multiply. So it comes with its own viral RNA, enters the cell, adopts the host cell, adopts the host DNA, and make its own complement DNA. And from this, it makes its own what? More of its own viral RNA, and makes eventually more of its own proteins. So every antiretroviral drug are meant to stop the different stages that HIV goes through to accomplish the goal. Then we look at what is the aim of treatment. One, the aim of treating HIV here is first of all to slow down the clinical progression of the virus from HIV to AIDS. We want to slow down the clinical progression of the virus. Secondly, we want to reduce the frequency of opportunistic infection. Thirdly, we want to also reduce the development of resistance once treatment has started. And how do we reduce the development of resistance? We don't give a particular drug in a drug class. We give a combination of drugs from different drug classes that is known as this ARTs, highly active antiretroviral therapy. Usually, we give two NRTIs, two drugs from this class, one drug from this class, one drug from any of these classes, one or two. So usually a combination of 4 drugs, 2 from NRTIs, 1 NNRTI, 1 PI, and possibly one other drug like that. So let's look at the first group, NRTIs. NRTIs are known as a nucleoside or nucleotide reverse transcriptase inhibitors. So from that name, you can easily deduce the name of the enzyme involved here, reverse transcriptase. So the goal of the drug is to inhibit this enzyme, reverse transcriptase. So this transcriptase is necessary for entry and progression of HIV. So just like lamivudine, abacavir, dilanozine, stavudine, zidovudine, and the likes would inhibit reverse transcriptase enzyme. That is what this drug class will do. The second drug class are the NNRTI, which are known as what? The non-nucleotide reverse transcriptase. So these drugs will inhibit the same enzyme non-competitively. So example of drugs here are efavirenz and nevirapine, and also efavirenz is also used to prevent or to reduce the transmission of maternal to fetal HIV transmission. Also, so we have efavirenz and nevirapine being used for this. The third drug class here are the PIs, which are now protease inhibitors. So the proteases are also enzymes in the HIV that are inhibited by this drug, like ritonavir, saquinavir, and the likes of them. So the MOA of the drugs aim to inhibit the proteases. Proteases are also enzymes needed by HIV to also help them to migrate from where they are into the old cells and deplete the CD4 cell count. Now there is a drug class here. There's this drug called AntiRetrovirals, which is a CCR5 antagonist, right? So AntiRetrovirals inhibits this pathway that HIV needs to enter the cell. It's either the CCR5 pathway or the CXCR4 pathway. So AntiRetrovirals specifically inhibit this pathway. So some textbooks will class AntiRetrovirals as an entry or fusion inhibitor, but when it is discussed, it is always discussed as a CCR5 antagonist, and that's why we have it as a CCR5 antagonist. It antagonizes that pathway. The other pathway is the integrase inhibitor. So the same thing. These are all enzymes. Ratigravi, elvitigravi will inhibit the integrase enzyme that also integrates the old cell with the viral cell. Coming to the fusion and entry inhibitors, we have enfuvityl. Fusion and entry inhibitors are some of these that are at the later stages of HIV. It will inhibit entry. It will inhibit entry into the old cell or limit entry and modification. So the last drug class that is also used as an adjuvant therapy are what we call pharmacokinetic enhancers. E.g., we have ritonavir, we have obisistate. You remember that ritonavir has been discussed as a PI, a protease inhibitor, but ritonavir has also been found or proven to improve the pharmacokinetic profile of other antiretroviral drugs. So it can be given as an adjuvant therapy to improve absorption, distribution of the other drugs. In a way, it increases the half-life and effectiveness of other drugs. So basically, these are the drugs we use in the treatment of HIV. And like I said earlier, you cannot use just one drug in a drug class. Now we have to have a combination of 3 or 4 drugs to ensure that the viral load is brought to a level that is now almost undetectable in blood, in the blood. And it has also been said that none of these drugs have been proven to stop HIV transmission from persons to other individuals, so that the person has an undetectable viral load does not mean that person is being cured. We know that for now, most of the mainstream drugs don't cure HIV/AIDS. They would only ensure that the person can live a high quality of life. They reduce mortality rate and morbidity in individuals. They restore the immune system gets to come to a normal level where the CD4 cells and CD8 cells return to normal levels, pre-infection levels, and that is what we need. And although these drugs are so toxic, eventually what we do is we intend to manage the toxicities that develop alongside treatment. So, thank you.